So here's another indefinite integral that initially looks pretty intimidating. We have division going on here. We have a composition of functions, right? We have a chain, outer function square root, inner function what's underneath it. There's not really an antiderivative formula that allows us to find the antiderivative of this, but when I look at what we have within this particular antiderivative, I think it kind of resembles an antiderivative formula that we've used, and that's the antiderivative of 1 over the square root of 1 minus u squared with respect to u is going to give us inverse sine of u. So I'm thinking that we might be able to see if we can manipulate this integrand to the point where it looks like this, and then we can use this as our means of finding our antiderivative. And so you'll see what I did is I started to kind of manipulate what's underneath that root a little bit. So I left the -5 out at the front because I'm looking at this root within this integral formula, and we definitely see the constant value is listed first. And then what I did is I grouped the -x squared term and the plus 6x term after that -5 within the denominator. And I'm thinking, well, maybe I can use the process of completing the square in order to get myself to the point where I have just one thing being squared that's subtracted from the 1 within that denominator. And so the only thing that you have to make sure you recognize about the formula for completing the square is that it only works when the coefficient of x squared is 1. And right now, within this set of parentheses, the coefficient is -1. And so we've got one quick step to do before we're going to be able to do any completing the square, and that's to get the -1 factored out in front of this set of parentheses. And that's kind of a nice step to do because when we factor the -1 out in front of this set of parentheses, it also changes the denominator to a subtraction problem, which is really what we wanted underneath that root. And so I factored -1 out of the x squared, got positive x squared, factored the -1 out of the 6x, got -6x, left myself a little bit of space because I know I'm going to try to complete the square here so that I can turn around and factor what's in this set of parentheses as one thing being squared. And so I realized that if I'm going to create a perfect square trinomial in this spot within the denominator, what I'm going to need to do is I'm going to need to take b, which is -6, divide it by 2, which obviously gives me -3, and I'm going to square it, and that's what I'm going to put in this position right here. So b over 2 squared is +9. Now I can't get away with just putting a +9 in this position right here. Now what's tempting to do is to say, well, I just put a +9 here, so to offset that I'm going to do a -9 outside that quantity. And normally that would be okay, but think about what we did a minute or so ago. We factored out a -1. So I did put a +9 in this spot within the set of parentheses, but the set of parentheses is really being multiplied by -1. And so what I really put into this denominator is -1 times +9. I really put a -9 into the denominator, and to offset a -9 I'm going to have to do a +9 because those two things going into the denominator end up canceling out and becoming just like adding 0. And so this offsets the -9 that really got put into this position right here. Then you're going to realize, hey, the -5 sitting here and the +9 that's after that quantity that we just completed the square within, those are like terms. So -5 plus 9 takes me to +4. I just completed the square right here. If I try to factor this, I'm going to see that it's x minus 3 times x minus 3, or x plus b over 2 squared, and b over 2 is -3, so we get x minus 3 quantity squared there. So now this is more closely resembling what we have up here. Next issue is making sure that that constant value that's the leading term under the root is really a 1. And so I wanted to turn the 4 into a 1, and I have to do something that keeps this expression equivalent to what we began with. And so what I'm doing is I'm factoring a 4 out of the two terms within the denominator. If I factor a 4 out of 4, I do get 1, which is the whole point of doing that. It's a little nasty to factor 4 out of this because when you factor 4 out of this term right here, you have to divide that term by 4. But you can hopefully convince yourself that when I distribute to undo the factoring process, I do get from this back to what we started with on this middle line right here. And so there's a little bit more manipulation that we can do, and we're almost to the point where we're going to be able to do a u substitution and be successful with using this antiderivative formula. You do see that we don't want that square root of 4 times this quantity that's also underneath the square root to be there. We would rather get this number out of the way. And so now that you have a multiplication problem under the root, you can't do it when it's, two separate pieces. I can't do the square root of 4 and then subtract the square root of this from it. But now that this is multiplication, I can take the square root of 4. Square root of 4 is 2. Now that square root of 4 is in the denominator though, so if I want to factor it out in front of the integral, I have to make sure the square root of 4 or the 2 stays in the denominator. And then what we see here is not just one thing being squared, it's something squared, but then divided by something else. We would rather have this expression here be one thing being squared. And so we can actually include the 4 as part of the quantity that's being squared by putting it into the parentheses that are being squared in the denominator of the fraction. But of course, we're going to have to turn it into a 2, right? We want the 4 to be represented by a 2 that's being squared within the denominator of that fraction. Check out what's right here. If we let u equal what's right here, we've now created exactly what's inside this integrand up here in the upper right that we've been referencing off and on throughout this problem. So if we let u equal what's inside that set of parentheses, and again, you're probably going to want to simplify this a little bit before taking the derivative. This is 1x minus 3 over 2, so that's really 1/2 x minus 3/2. Well, what's the derivative of u with respect to x? Well, if you do the derivative of this form right here, you end up with 1/2 for the derivative of this term, and then minus 0 for the derivative of that term. So what does dx equal? Well, multiply by the dx, multiply by the 2, and 2 du is going to go in place of the dx. So here's the integral that we can create. We have this 1/2 out here right now. We just inserted a 2 as part of what was replacing the dx. And so these are actually going to be able to cancel with each other as well. 1/2 times 2 is just 1. So those take care of each other. You see the 1 represented there. What's the antiderivative of 1 over square root of 1 minus u squared? Well, it's inverse sine of u plus a constant c. You want the original variable in your answer, so substitute this back in place of u, and you have your antiderivative.